These are the inverse functions of the hyperbolic function. So if the function is hyperbolic sine, then the inverse, we call it inverse hyperbolic sine, is equal to the natural log of x plus the square root of x squared plus 1. If the function is a hyperbolic cosine, then the inverse is natural log of x plus the square root of x squared minus 1. The difference here is this is plus, this is minus. And then the inverse hyperbolic tangent is 1/2 natural log of 1 plus x dividing by 1 minus x. And the inverse for the hyperbolic cotangent is 1/2 times the natural log of x plus 1 dividing by x minus 1. And inverse for hyperbolic secant is natural log of 1 plus the square root of 1 . And hyperbolic secant is natural log of 1 plus the square root of 1 minus x squared dividing by x. And inverse for hyperbolic cosecant is 1 natural log of 1 over x plus the square root of x squared plus 1 dividing by the absolute value of x. And let's prove the first one, and the others should be similar. So we want to prove that the inverse, so we have the function y equal to hyperbolic sine of x, by definition is e to the x minus e to the negative x divided by 2. And we want to prove that the inverse function is natural log of x plus the square root of x squared plus 1. And so recall that to find the inverse function, so this is the function right here, and we want to find the inverse function. And so what we do is we interchange the x into y. So in the place of y we put x, in the place of x we put y, and then solve for y. So y here becomes x, and then x e to the x becomes e to the y, e to the negative x becomes e to the negative y, and then dividing by 2. And so from this equation, we replace the y with the x, replace the x with the y, and then we need to solve for y. And that will give us the inverse function. And so from here, multiply both sides by 2, multiply the left side by 2, multiply the right side by 2. Then we get 2x. And then for this part, we get e to the y minus e to the negative y. And then subtract minus 2x from both sides, and then we get e to the y minus 2x, and then minus e to the negative y. And then from here, multiply each term by e to the y. So multiply this term by e to the y, multiply this term by e to the y, and multiply this term by e to the y. E to the y times e to the y is e to the 2y, which is at the exponent. And then here we get negative 2x times e to the y. And then right here, negative y plus y to 0. So we end up with e to the 0, and e to the 0 is just 1. And this is e to the 2y, so we rewrite it as e to the y to the second. Remember that if we have an inside exponent and an outside exponent, we multiply them. So right here, 2 times y is just 2y. The reason we need it in this form so that this could be, and so that this is can be in what's called quadratic form, and so we can use the quadratic formula and solve for it. And so we end up with e to the y squared minus 2x times e to the y, and then minus the constant 1. And so now this is in what's called quadratic form. And so we can use the quadratic formula and solve for e to the y. And if we use the quadratic formula, then the constant right here is 1. So the constant in front right here is 1. So 8 is 1. And then the constant, the coefficient of e to the y is negative 2x. And then the term here is negative 1. So we have 8 is 1, which is the constant in front of the e to the y squared. And then the coefficient of e to the y is negative 2x. And then c would be negative 1. And so we get e to the y is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. 8 is 1, so we get 2 times 1, which is 2. b is 2x, it's negative 2x. b is negative 2x, and so negative b will be 2x, and then plus or minus. b squared will be 4x squared, and this will be negative 4 times 1 times negative 1, and we get positive 4. The common factor here is 4, so the common factor is 4. And so this becomes 4 times x squared plus 1. But the square root of 4 is 2. And so that's how we end up with 2 times the square root of x squared plus 1. One more time. The common factor here is 4. And so this becomes 4 times x squared plus 1. But the square root of 4 is 2. And now we divide everything by 2. So divide 2x by 2, we get x. Divide this term by 2, we get the square root of x squared plus 1. And then divide this by 2 and we get 1. And so we end up with e to the y is x plus or minus the square root of x squared plus 1. And then now take the natural log of both sides, so we get natural log of e to the y is equal to natural log of x plus or minus the square root of x squared plus 1. And recall that the natural log of e to the y is just y. The square root of x squared plus 1 is larger than x. So x is smaller than the square root of x squared plus 1. And if we do x minus the square root of x squared plus 1, but x is smaller than this, we get something negative. A natural log of a negative number is undefined, and therefore the negative is extraneous. And so we get y equal to the natural log of x plus the square root of x squared plus 1. And we have just shown that the derivative of the, not the derivative, but the inverse function of the hyperbolic sine is the natural log of x plus the square root of x squared plus 1. So we have just shown that the inverse hyperbolic sine is natural log of x plus the square root of x squared plus 1. And now let's find the derivative for sine, for hyperbolic sine inverse. And so this is the natural log of x plus the square root of x squared plus 1. And so the derivative of this function will be 1 over x plus the square root of x plus 1, and then times the derivative of x plus the square root of x plus 1. The derivative of x plus the square root of x plus 1, we have the derivative of x, which is 1. And now let's do the derivative of the square root of x squared plus 1. And so we need the derivative of x squared plus 1. This is the same as x squared plus 1 to the 1 half. So the derivative be 1/2, and then x squared plus 1, and record that the derivative, we move the 1/2 and place it in front of the x squared plus 1, and then subtract 1 from 1/2, so 1/2 minus 1 is negative 1/2. And then the chain rule says we have to multiply it by the derivative of x squared plus 1. So we get 1/2. And this right here, this, we'll go ahead and write it down right now. And then the derivative of x squared plus 1 would be just 2x. 1/2 times 2x, which is x. And then we'll go ahead and rewrite this right here as 1 over x squared plus 1 to the 1/2. So we get x. And then the bottom, the 1/2 is the same as the square root plus 1. So the derivative of the square root of x squared plus 1 is x dividing by the square root of x squared plus 1. And so we have the derivative. So once again, derivative of x is just 1, and then derivative of square root of x squared plus 1 is x over the square root of x plus 1. And then this right here becomes the square root of x squared plus 1 plus x dividing by the square root of x squared plus 1. But this is x plus the square root of x plus 1, and this is also x squared. This is also x plus the square root of x plus 1. Once again, this is x plus the square root of x plus 1. This is also x plus the square root of x plus 1. So this will cancel out. And so what's left is just 1 over the square root of x squared plus 1. And so the derivative of the tangent of the hyperbolic sine inverse is 1 over the square root of x squared plus 1. And so we have just shown that the derivative of the hyperbolic sine inverse is 1 over the square root. And we use x, but if we use the letter u, then it becomes the square root of u squared plus 1. And if we go through that same procedure again, then we will find that the derivative of the hyperbolic cosine inverse will be 1 over the square root of u squared minus 1. And the derivative of the hyperbolic tangent inverse will be 1 over 1 minus u squared. And the derivative for the inverse hyperbolic cotangent is also 1 dividing by 1 minus u squared. And derivative of hyperbolic secant inverse will be negative 1 dividing by u times the square root of 1 minus u squared. And derivative of hyperbolic cosecant inverse will be negative 1 dividing by the absolute value of u times the square root of 1 plus u squared. Here we have the function of inverse of hyperbolic sine of 15x, and we want to find the derivative. And so we have just seen that the hyperbolic, the derivative of the hyperbolic sine inverse is 1 over the square root of u squared plus 1. And so the derivative is going to be 1 dividing by the square root, and this will be squared, and so it will be 15x squared and then plus 1, and then we have to multiply by the derivative of the 15x. And so 15x squared is just 225x squared. And then the derivative 15x is just 15. And so the answer would be just 15 over the square root of 225x squared plus 1. Here we have the function 7x times the inverse, hyperbolic cotangent, and then the 5x, and we want to find the derivative. And so this is a product, so we have to use the product rule. And so it would be 7x times the derivative of the second factor here, and then plus the second factor times the derivative of the 7x. The derivative of the 7x, which is 7, and then now we need the derivative of the inverse hyperbolic cotangent, and we have just seen that the derivative of hyperbolic cotangent is 1 over 1 minus u squared. And so in the place of u, we have 5x, and then we have to multiply by the derivative of the 5x. So the derivative of 5x is just 5. And so altogether, 7x times 1 times 5 will be 35x. And then we can put the 7 right here. And this is the answer.